Hi, good evening, everyone. We are back once again for another TezAsia Hackathon workshop. We have two workshops lined up for tonight, and now we have with us Anshit. Anshit, who is the CEO of Geek Games and lead developer of Desotopia. He will be giving us a workshop on token standards on Tezos, FA1.2 and FA2 Fungible token. Yep, Anshit, go ahead.
Yeah, good evening, everyone. Okay, let me just share the screen. Yeah, can you see it?
Yes, I can see it.
Okay, cool. Okay, I should start now. So, welcome to TezAsia Hackathon. Today, I'm going to talk about Tezos token standards, which are FA1.2 and FA2. Particularly, I'm going to talk about fungible tokens, and we'll talk about how to create your own token. So let's dive into it. So today we'll talk about what are tokens, its use cases and types of tokens and token standards on Tezos, which are FA1.2 and FA2. And at last, we'll see how to create your own token. Okay, so what are tokens? So tokens are digital assets that are stored on blockchain. So these are defined by some code on the blockchain. If it's a native cryptocurrency of a blockchain, its code is defined in the blockchain itself. But otherwise, if we are going to create our own tokens on top of it, we need to create a contract for it, and it will define how the token will work. And tokens can have some realized value, like let's say if there's a popular artist creating an NFT, so it will have some value. Or otherwise, if there's a token which has some real world use, or maybe it's a DeFi token, so they can have some value in real life. So and these can be bought, sold, or exchanged between users. On if it's an NFT, it can be traded on an NFT platform. If it's a DeFi token, it can be exchanged on a DEX, a decentralized exchange. So, for example, Tez is the native token of Tezos. So it is used to pay for the gas fees and all the transactions that we perform on Tezos. And there can be other tokens which are built on top of Tezos. So, for example, we have KUSD and UUSD, which are stable coins built on top of Tezos, and Plenty is a DeFi token. GIF is like a DAO token, and Uno is a in-game cryptocurrency on top of Tezos using some smart contracts. And then let's talk about use cases of tokens. So most basic uses for cryptocurrencies. Uh, so there are some native cryptocurrencies of each blockchain which are used to pay for the gas fees, or which are used to buy sell stuff. So that is the basic use case of tokens. But otherwise, there are a lot more use cases like NFTs. So these are digital assets which can be as simple as a artist digital um, art, or maybe it can be an in-game asset, or maybe some other use case. And then there are stable coins which has some value associated with the real world asset. So let's say there's a stable coin of USD, so it will resemble the value of US dollar. And there can be liquidity pool tokens which are used in DeFi and decentralized exchanges, and they can be in-game currencies also. And there can be a lot more use cases of tokens. So I'll broadly divide the tokens into two categories. First is fungible tokens, and then non-fungible tokens. So there can be a lot more categorization of tokens, such as maybe people may call some utility tokens, some native tokens, maybe some in-game currencies, NFTs, and all this stuff. But broadly, they all can be categorized into fungible and non-fungible tokens. So in Fungible, we have the most basic, the native cryptocurrencies, and DeFi tokens and in-game currencies. So for Fungible, the concept is this: that if let's say I own one Tezos and someone else owns one Tezos, so they are both the same thing. So if I have one Tezos and I give it to another person and I receive some another one Tezos, so it will be the same thing. But for non-fungible asset, they are like completely different. Each non-fungible asset is separate from the another. They are not equivalent. So their use cases can be NFT, which can be a digital art piece, or some in-game asset, and some other use cases. And as we have as we know about tokens now, so we'll go into creating our own token. But to create our own token, we need to know what are the token standards that we need to follow for creating a contract for it. So why is the token standard required? It is because let's see, you know that a token is that many people will be creating tokens on a blockchain, and wallets may need to show them on your wallet that all the tokens you own, the balance will be shown in your wallet. And if you want to trade the NFTs, all these NFT should be tradable on an NFT platform, and all the fungible tokens should be tradable on a DeFi platform. So for to make this thing very easy and to make the integrations of all the tokens possible with all the different platforms, we need a common standard so that all the tokens have some common functionality. So we don't need to integrate each and every token separately. So this makes the integration very easy. So that is why we need some token standards. On Tezos, we have two kinds of token standards. The first is FA1.2, and then we have FA2 token standard. The FA2 token standard is older one. It is used to create fungible tokens, and one contract of FA1.2 standard will contain only one token, and it is very similar to ERC20 standard that you see on Ethereum, and it is defined on TZIP 7. And FA2 is a more versatile standard, and it can be used to create fungible as well as non-fungible or even semi-fungible tokens. And it can be used to create multiple fungible tokens inside the same contract, and it is defined in TZIP 12. So let's get into FA1.2 standard now. So it is described in this proposal. So okay, so I'll go to this side. So this is the TZIP 7 standard, which defines FA2 contract, FA2 standard. And this is the document describing it completely. You can have a deeper look into it, but let's try to see all the important things. Like you can see, it requires some entry points. Entry points, as you know, are the like are similar to functions that you use to interact with the contract. So it includes some simple contracts, simple entry points like transfer. So basically, you need to transfer your assets to someone else. So that it is very important for a fungible asset. So there's a transfer function, and there's a approve function. Approve is used to allow someone else to use your token on your behalf. It will become very much clear to you once you start creating DApps which use these tokens. So if a DApp contract requires maybe a DeFi contract requires to spend your tokens on your behalf, so you need to give it some permission to use your tokens. So you have approved. One cool information about this is that you can define the amount of token that you want that person or that address to use. So he will not be able to use all of your tokens, but only some amount that you have approved. So that is one cool stuff. You can also get the balance that you have or total supply, and see if someone is allowed to use your contracts. So these are the main functions that it should have, and it can also have some other function if required. And you need to have some kind of metadata to describe what kind of token it is. So you can learn more about it in TZIP 12. Um, we'll look into it later. And this is description of all these entry points. You can have a deeper look into it. And I'll quickly go into an example of FA2 standard. Let's look into Plenty. So Plenty is a token which is based on the FA1.2 standard. So this is tzt.io on which we are seeing this token, and these are the transactions happening on this contract. And we'll see the entry points here. So you can see it has a transfer entry point, as we saw in the standard. It should have a transfer entry point, and then approve also. And all the get allowance, get balance, and get total supply. These were the ones defined in the standard, but it also has some more like burn, mint, and all the different, which are like custom made entry points which can be added to. But you should basically have at least transfer and all the 5 entry points that were defined here. Yeah. Okay. So let's take a look at the storage of this contract. You'll see here's a balances big map. So this will store all the balances of all the different owners or holders of this token. So let's say this address has some kind of, so this is the key here, and it contains this balance value. So this address has this much tokens, this much plenty tokens as of right now. And also this tells us about the approval that it has given to all the other contracts that it has ever interacted with. So currently it has zero approved tokens, but when he was maybe interacting with this token, then he may be having some defined value here. Okay. Um, so this is all that I wanted to talk about FA1.2. You can also see the FA1.2 standard template on SmartPy if you want to create a FA2 standard, FA1.2 standard contract. So you'll find it in the templates, the token contract. You'll see FA1.2 fungible asset contract. You can use this to deploy your own contracts. And do you have any questions till now?
Yeah, actually, we have one question from the chat. Do Tezos also have soulbound token?
Okay, so soul-bound tokens are a very simple concept. This is a token which cannot be transferred by yourself to anyone else. So this is like bound to your soul or maybe your particularly your address. So you can't transfer it to someone else. So to make a soul-bound entry, to make a soul-bound NFT, but mostly, I think Soulbound is for NFTs, not for fungible tokens. But if you want to create a Soulbound fungible asset, let's say, so if you want to create it using PZIP 7 standard, um, see, we have a transfer entry point here. We'll just add a line that this entry point should fail. So let's say we have an entry point here. So for, okay, yeah, went back. So you only have to add a line that the entry point call should fail at every time. So no one will be able to transfer this. But to create an NFT using this, we'll have to go into the FA2 standard where we can create the NFTs. And in that entry point, in the transfer entry point, we'll add a line. Let's say, let's find the transfer entry point here. Yeah, we have the transfer entry point here. So we'll just add a line here, which is sp dot fail with. We'll add an error. Um, Soulbound NFT uh, can't be transferred. Yeah, so that's it. So you just need to fail this, and you can also remove all this code so no one will be able to ever transfer it. But you do need to include this entry point because it is written in the standard that you need to have this. But basically, you just have to make it fail so no one will be ever able to transfer it. So this is how you make a soulbound NFT. Okay. So this was FA. So do you have any other questions?
No, that's all of the questions. Actually, one person is asking whether you can provide all the links that you have in your presentation.
Yeah, sure. I'll share the presentation and you can view all these links directly from here. Yeah, and this was all about FA1.2 standard, and now we can go into FA2 standards. So it is a more versatile standard, and using it, you can create a lot different variety of assets like fungible as well as non-fungible and multiple fungible tokens inside the same contract. So let's go into its description here. And by the way, this is a very useful site. So this include all the TZIPs, which are Tezos um, improvement program. All the Tezos improvement proposals are given here. So you may find, so this is for the TZIP 7 and we are now at TZIP 12, which is FA2 standard. And you can also find another interesting proposals here. So let's go into TZ12, which is FA2 standard. Um, so basically, it should have these entry points. These are the mandatory entry point FA2 contract should have. So this is transfer, balance of, and update operator. So this update operator is very similar to the approve entry point that we had here, but the difference is that while adding an operator, we are allowing some other address to use our tokens, and he can use any amount of tokens that we have. So in FA7 standard, we were able to define some value that this address can only use this much of my tokens. But in FA2 standard, this there is no such provision. So we'll be giving access to all of the balance that we have of a particular token. So this can be a security risk, but you need to make sure that this doesn't happen. Okay, so all the NFTs that you can see the transfer entry point. This may look a little complex, like you need to put the parameters in this type, but this is the Michelson type. You can see the simpler type on SmartPy here. Yeah. So we'll go into the code later. Okay. Yeah, so we have a transfer entry point where we can actually transfer the token to many different people at the same time. So we can use a from address, like from which account we want to transfer it. And inside the two, we have a list of items where we can like give to which address we want to give and which token ID. And like as I said, there can be a lot of tokens inside a single contract. So we have a thing known as token ID. So it starts with 0 and next token will be called token 1. So the token ID, the address to which we want to send, and the amount of tokens we want to send. So we can batch it up, and using one from address, we can create a list of these three parameters and we can send it to multiple people in the same call. And then we have a balance of it is a callback entry point, so it can be used by another contract to know the balance of tokens that someone holds. And then there's an update operator, but you don't have to go into too depth here because you will be mostly using SmartPy or Lego. So um, let's first take a look at example contract here. So this is the token. So this is a FA2 token contract of Tezotopia, where we have four different tokens. So let's say, so these are the token IDs. So we have a 0 token ID, 1, 2, and 3 token ID. So these are all four fungible assets of FA2 standard. And the first token is Uno. So this is the symbol, and we want to know about the metadata, like how do we put this image here, how do we name it, and all the stuff. So we can take a look at it and we can see the metadata. So this is also defined in TZ12. If you look down here, so this is the token metadata that we need to follow. So basically we can create a map which can have an empty string, and beside it we can have a IPFS link, and inside it we can put a JSON just like this, and it should have a name, a symbol, and decimal, a description, and a thumbnail for this thing. Yeah. So decimal is very important here because it is a fungible asset. So most blockchains or and also Tezos does not allow us to use floating point numbers because that can be harmful. So we only have net or int. So to use decimal placed tokens, we have to use this field. So if someone has, let's say, a billion Uno tokens on chain, but a wallet will just show it as one token because it has 9 decimal places. So all the 9 zeros will be behind the decimal. So we'll take a look, a more deeper look later. Okay, so let's go into the entry point of this contract. So here we have the balance of entry point as we saw in the standard, and we also have transfer and update operator. All the other are not compulsory, or there are optional as well as custom entry points that we need to mint these tokens, and also maybe change its metadata and things like that. So now we'll take a look at how we can create our own FA2 token. Okay, so here is the smart pie. We can use this template here. This is the FA2 template. You can use it. I've already opened it here, and I have also added some custom code at the end because this contract is too long, and it is too modular, so that it allows us to create any different kind of contract that we want to create. Like we can create an NFT contract, we can create a fungible asset contract, or we can also create a semi-fungible contract also. So here we want to create a fungible asset contract. So I created a new class, FA2 class, and using inheritance, I used all the options that all the features that we need in this contract. So all these classes are defined above. You can see the code later on. And like we need to have an admin for some kind of actions, like for minting new token or pausing the transfer of these tokens. We need this kind of functionality so that only admin can do that. So this class has some functionality regarding admin, like changing admin and all the stuff, and also change metadata if we want to change the metadata of this contract, or if we don't want it, we can just remove it from here. Or we also want to mint it, we also want to burn it. Burning means just deleting some amount of this token. So we can enter a token ID. We can say we want to burn this much amount of this token. So it will be just gone, deleted from the blockchain. So this is burning, and just other things like views to view the balance of any user using some other contract. Yeah, and this is the main contract that we are using. This is the main class that we are inheriting here, which is fungible FA2 fungible. Yeah, and we need to initialize it. So we have initialize function. We are taking the administrator and metadata here in the parameters, and initializing both these classes. We don't need to initialize others. You can check the code for more information, and we can also create other custom entry point that we want here. Like let's say I have created the entry point to change the metadata of any particular token, and we only want admin to change it. So we are checking if it is admin. Yeah, and if you don't want it, you can just remove it here. It will work perfectly fine. And then we have created a compilation target here. I named it as FA2 fungible compilation target, and we are sending the administrator address here that we want if we want to deploy it. So this will be the first admin of this contract, and we have used a sample metadata right now. Yeah, so let's try testing it. Let me know if you have any questions. It will take some time.
Someone, Angie, someone from the chat is asking, why do we burn tokens?
Okay, so it really depends. Like you can do anything with your own tokens, but in normal crypto projects, like you have to know about the tokenomics of this. Tokenomics means the economics of your tokens. So these are like real world currencies where you need to maintain the prices of these tokens. You have a lot of things going on with it. So if you want to maintain the price, there are things called like inflation, deflation, and all the stuff. Like if your token is being minted again and again, its amount will be increasing, and if there is not enough demand, its price will decrease. So to compensate for the inflation caused by minting more tokens, you may want to burn some of it at some times. Okay, so this is the tests have run, and now we can call this particular compilation target. This is this one here. Okay, so this has been compiled, and this is how the parsed contract code looks in SmartPy, and we can also see the code in Michelson here. So I don't know what it means, but hopefully it's the conversion of this SmartPy code to Michelson. Yeah, so now we can deploy this contract. Let's try deploying it. Okay. I'll use Ethernet. I also recommend you to use Ethernet because it has now been converted into GhostNet, which is a permanent testnet on Tezos. Otherwise, JakartaNet may soon be deprecated, but Ethernet is now a permanent testnet, which is also called GhostNet. So I will connect my wallet. Okay. Yeah. So let's estimate the fees for this operation, and then let's try deploying it. So maybe the fees was a bit less. Or if this node is not working, I tried it with a custom node. You can also find these from Taquito's documentation, all the nodes. Okay, let's try it with this one. Okay, estimate the fees, then deploy. Yeah, it got deployed. The transaction has been injected into the blockchain. We'll wait for the confirmation here. Yeah, so this is confirmed, and this contract has been minted. We'll use better call dev to look into the contract. Yeah, we can also use tzkt.io, but for developer purpose, for testing the contract, I think it will provide more information, better call dev. So this has been originated, and you can look into the details that this administrator has been set to this address that we defined right here. Yeah. Okay. And this metadata that we defined here is sample metadata, which does not contain anything and it is invalid, of course. But if it was a valid metadata, it must be showing right here, like this contract address will be uh, replaced by its name that we defined in the metadata. But this was contract metadata. This is not much important, but more important is while minting the NFTs, we need to provide some metadata for the NFT or the fungible asset that we are minting. So we saw the origination operation. We can see the storage here. It has a ledger where all the tokens, the users, and their balances will be listed. And this token metadata will contain the metadata of each of the tokens inside this contract and all this similar stuff. And let's look at the entry points. These are all the entry points that this contract has. And we are now going to mint the first fungible token inside this contract. So yeah, it provides some mint functionality. Let's say we want to uh, mint one amount of any token. Um, we are minting a new token here, and we need to add metadata to it. So as we discussed, as we saw in this token metadata, as in the TZ12 standard, it requires a map. So this is of course a map where we define the key and the value of it. And here we are going to set the key as this empty string, and in the value we are going to put IPFS address, which will contain all the metadata. So for example, let's try using metadata of unobtainium. So this is the contract for Uno. Let's check its storage, and we can find the token metadata here. For zero token ID, which is for unobtainium, we can find its metadata here. So it is a map of empty string with the IPFS link. So let's open it. Yeah, so you can see this is the metadata for unobtainium. This is a fungible in-game asset of Tezotopia. This is the name, this is the symbol, this is the description, and this is the decimals. I'll show you how decimals is being used here. Um, okay, so let's copy the IPFS address of this metadata. We'll use the same metadata, but you see here we need it converted into bytes. So bytes is basically a hex encoded string. So we'll use any online tool to convert it. So we have this, but we need to append, we need to insert at the beginning IPFS. So it knows it's IPFS link. Okay, separated by none and converted. So this is the bytes that we want to put right here. with an empty string that was defined in the standard. So we need an empty string. So we are giving it an empty string. And then we need to decide to which address this amount will be transferred. So anyone will be holding this amount initially when this is maintained. So let's use my own wallet. Okay, I'll copy this and paste it here. But as you saw that this token has, let's open it again. This has 9 decimal places. So it means that nine of the first digits from the amount will be like skipped. The decimal point will come after 9 places. So if we are putting it as one amount, so it will actually be 0.8 zeros with one at the end. So if we are putting 9 zeros here, 1, 3, 6, 9. Yeah. So this will actually be unobtainium token because we have 9 decimal places in the metadata. So 9 zeros will be skipped and it will put a decimal place right here. But as you know, decimal places are not allowed inside the blockchain on contracts. So we are using it as an abstraction, like we are showing the decimal places only in the front end in your DApps or in your wallets, but not on the contract itself. So it requires all the zeros, the 9 zeros, or maybe it can be a random value, not the zeros. So the wallet will show 1.000 this kind. But if you want, like, let's say 1,000 Uno, so you'll need three more zeros here. Yeah. So if you think it's a very long number, you can also like decrease the zeros in your decimal places. Yeah. So if you can use, like, let's say 0 also, or maybe 6 is also a very common number for decimals. Okay. So let's just mint it. Okay. I'll use my Temple wallet. So one thing to consider that only an admin can mint it by default. So I'll use the same account which was set the admin. Okay. So I have confirmed the transaction. So let's wait it to get confirmed, and we'll see the transaction here when it is confirmed. And we can also open this now on TZKT on GhostNet because we deployed it on Ethicanet, or it is now called GhostNet. So let's open this contract here. Yeah, so this has been minted now. And if I check the tokens here, you'll find that this is the zero token ID that has been minted already on it. And if we see the token, we'll see that this address, which is my address, minted this much amount of tokens. But this does not already know that these are the decimal places and it should show 1000 here. And we can also find the metadata, but this is not yet parsed the metadata. So it should be taking some more time to parse it. And after that, we'll be able to see the uh, token thumbnail here, and also the decimal places will be decreased. Or otherwise, you can also see it later in a wallet right here below this. Yeah, so now you can see we have 1000 Uno. So this has been passed. Yeah, now it has all the metadata. And I'm the sole holder of this token right now. So of course, it does not have any value that it is on testnet, and only I'm holding it. So I have 1000 Uno now. And I can also transfer it to any of my friends directly from here once it gets added here. Okay. So now you know how to create your own fungible assets. So this was all from my side. Thank you. So any questions?
Yeah, we have a couple of questions from the chat. The first one is,
Okay.
it's saying wrong token when he's entering the two FA code. I'm not sure problem is that.
Sorry, I didn't understand. Okay, I'm browsing the questions now. So someone asked that it is saying wrong token when I entering the FA2 code.
Mm.
Okay. For that, let's follow the same steps that I'm taking here. You have to go into these templates inside SmartPy and choose this FA2 library contract, and this will provide you this all code all already written, because it is up to the standards and it knows what the code is already, so it has been defined, and you can use the same code to deploy a FA2 contract. But this is too much modular, so according to our use case, we need to decide what kind of functionality do we want in our contract. So at the end, I have created this FA2 class, which inherits all the functionalities that I need. I'll share it so you can use the same contract, or you can also customize it if you like. Let's say you want to add some other kind of things to its storage. You can also add other kind of functionality here. You can also add other functions here, or you can also edit some kind of functions from here. Like let's say you wanted to create a soulbound NFT. First of all, if you want to create an NFT, you will be using here FE2 NFT class, not FE2 fungible class. FE2 NFT class is also available in this code above. And but all these NFT will have only one amount. But if you want NFTs with multiple editions, which are also called semi-fungible, then you will be ultimately have to use this same fungible class. So I'll be sharing this code. So this is the same NFT contract that we had in the templates, but I have only added this. And compilation target is very important because we want to tell SmartPy that we want to compile it using this address and this. If you don't provide it, if you use the addresses that are inside the test cases, those addresses are not valid in real world, so it will compile in that code. So you need to have a real account or any other. So I'll share it later. Okay.
Another question is, what other permissions can admin have other than burn and mid and user check?
It totally depends on you what all permission you want the admin to have. Like if it's a totally decentralized token that you don't want admin to have no access at all, you can also remove the admin. Like if you see here, admin is not at all described here. Like if I find it, yeah, you can like this says that update operator. You can also add some kind of code like if owner is sender or be limited to administrator. Like you can let the administrator use update operator or maybe the transfer function. Like it says it you can use it, but it's not required to have any kind of admin functionality in your contract. So you can have a contract which does not allow you to mint more token, but like let's say you have 1 million of a token and you won't be able to mint more of this token again, so you don't need admin in that kind of situation. So and also we can also let the admin transfer any user's token if we want. So for that, let's go to the code again. Let's find the transfer function. Yeah, here we have the transfer function. So here we are checking if so do we have a verified statement? Yeah. Yeah, so this is like a very complex code. Like this is using another function from above, where it is checking that if this user is allowed. So this will be allowed if it's the operator or it is the owner of the token that he is transferring. So you can find the token, this code above in the same content in the same code. But if you want the admin to transfer these, you can edit this function above, and you can also add if sender is admin, so let him transfer anyone's token. So you can add that kind of functionality as you want. So
Another
someone is
question
asking how
is,
can we generate metadata? Like I want to create an NFT which contain user details. So as I talked about, there is a metadata which is defined in TZ12. So there are two kinds of metadata. One is contract metadata, which is defined in TZIP 16, and the token metadata, which is defined in TZIP 12, and it is extended in TZIP 21. So you need to study both. So you'll find some kind of common fields that you can use to define the properties. So this defines the basics of token metadata. So it just tells you that you need an empty string and beside it, you need to store a IPFS hash. So I think that is best. Otherwise, you can also store all the metadata on chain, but that will require a lot of storage fees. So that is not ideal. So you can store all of it in a JSON on in the IPFS. You can use Pinata for IPFS and just create a JSON with all the fields that are described in this here. Or you can check the TZIP21. Let's check it out. Okay. So it says basically a token should have these three fields. If it's a NFT, the decimals will be of course be zero because it can have only one uh, addition, one amount. Otherwise, like let's say for semi-fungible and NFT tokens, you will also require artifact URI, display URI, thumbnail URI. We also had thumbnail URI here for our unobtainium token. So this is another IPFS URL that let's look at it what it is. Yeah, so this is the image of this token. So this is a low resolution image as you can see. So this is the thumbnail. Otherwise, for NFTs, you will also require high resolution images or maybe you can have other things such as creator's name and address, and you can extend it, and it is very much extensible. Like let's say you can have attributes here. So attributes are the properties of your NFT. So if you have like let's say thousands of attributes inside your NFTs, so you want to describe your NFT in detail. So you can use this field, and inside attribute you can describe all the properties. Like let's say it is a property named base and whose value is starfish. Yeah. So I think these are all the things that you mostly need. And if you think you have some other kind of information that is not described here, so you can just create another field in your JSON right here, and there won't be any problem with that. And someone is asking, can token supply be increased after it's minted? So using this contract, using this code, it is possible to increase the supply, but only admin will be able to increase it. Okay. In the mint entry point, we'll just select existing. Like we want to mint the existing token, we want to mint the more amount of existing token, and we need to put the token ID here. So the token ID was 0, and I can mint like let's say uh, any amount of it and send it to any address. So more token will be minted with this code. But if we change it, if we remove the mint existing functionality from it, and then only once it will be able to mint and no more will be able to mint. It totally depends on you and your use case of the token. Okay, so that's all. And someone is asking about giveaways. So I think Ivan can tell more about that.
I think for those questions, we can go to the Discord, and then the Discord moderators and ambassadors will be the one giving more information regarding that. Anyway, thank you so much, Anshit, for this workshop. We'll have another one later at 6 p.m. IST or 8:30 p.m. SGT. Yeah, thank you so much, Anshit. Have a good day, everyone.
Okay,
Thank you.
thank you. Have a good day.